Do I project over the speakers like he, or no?
You have that thing.
Okay, so I have to, people in the room have to rely on the volume of my voice. That's okay.
What?
It's okay. We should be fine.
Wait, is it not working?
No, I think, all right. Stream stuff okay? We good to go? Microphone's on? All right. So my name is Brian Niskowski. I live in Ann Arbor as well, as most people in this room. I'm a cloud consultant for a company called The Head. We have offices in Chicago, Michigan, Wisconsin, a few around the Midwest. We do data center consulting. So I came up with this idea of VoiceOps. There's the thing that's kind of ChatOps that already existed. You'd be in Slack or IRC or HipChat or whatever you're, maybe what's the new one, River now, River. You type stuff in and it does stuff for you, and that's pretty cool. And one day I saw the Echo, and it was really kind of inconsequential. Then I kind of tied the two together. But kind of aside, I think the Echo didn't get much popularity until the whole Baldwin Super Bowl thing. So I mean, do people feel the same way? Before that, people were like, "Oh, what's the Echo?" And then now, as soon as Alec Baldwin orders some socks from it, it's like, boom, boom. I saw another article on LinkedIn today with the term VoiceOps, so it's apparently a thing now. Even though I just made it up off the top of my head, I'm like, "Oh, this is going to be a cool talk. I'm going to incorporate some Amazon Web Services stuff, talk into this spherical tube, and we'll go forward." So, for anybody who doesn't know Amazon Echo, what it is, it's this device on the table right here. Several features that can be outlined. It has microphones times 6 in this little area on top. Mute button, which later on maybe we'll discover, is it really muted all the time or not? Is Echo listening to you argue with your significant other or grumble about something else underneath your breath? That's for you to decide. Sorry, Amazon, but you got to disclose that info. It's got this fancy ring that has light show. White, blue, red lights kind of flash when you do stuff in response to your talk. This thing spins, turns the volume up and down, and we'll spill someone's beer over on the table here, but we'll be a little careful. It's powered with a DC power. You have to plug it into the wall, which is pretty annoying because if I'm in the kitchen chopping food, making stuff, I want to take a shower, I have to move the Echo, I have to unplug it, and it's got to reboot. It's a huge problem for me. I think they've solved that now with the tap, but I think with the tap, you actually have to go. So they introduced 2 new devices recently besides this. One is like a tiny little puck that doesn't have a large speaker, and one is a Bluetooth version. We have to actually press the button, then talk. I'm assuming you press the button because you can't be listening all the time or it'll drain the battery. So it's a huge inconvenience for me, like to have to unplug this thing, move it from my kitchen into the bathroom when I want to take a shower and listen to my jams. So hopefully they can build like a battery into it, and I don't need to actually press the button. I can yell to it from the shower. So that's my one rant about it. If you're like, think, oh, I have no room for this on my countertop. Well, if you have room for a can of pizza-flavored Pringles or 2 cans stacked of Wolfgang Puck-flavored tomato basil bisque soup, then you too can install an Amazon Echo in your kitchen countertop. So I bought the Echo. It arrived in my house. Talk a little about device setup. So it actually, when you unplug it for the first time and take it out of the box, it creates an 802.11 network and advertises the broadcast and SSID. Mine was Amazon-40H. This may vary. Like I only have one Echo to test with, so this may be an alternate SSID. So you actually, on your computer or mobile device, you download the Alexa app, or you go to alexa.amazon.com. And if you join the network, like the device also becomes the default gateway, which also handles DNS requests. So if you resolve alexa.amazon.com, actually resolves the IP of this device. So you're connected to a local 802.11 network. Then you actually communicate with the device locally to do its initial configuration. So I encountered a few interesting things when I first set it up. I have a 2.4 gigahertz and 5 gigahertz SSID with the same name broadcast in my house, and it would never connect to it. So I actually had to like disable the 5 gigahertz access point with the same name, and I was able to connect, and I could bring it back online. So interesting thing. It may or may not be the root cause, but I'm going to speculate here for that. So you use the little app or the actual web page, which I believe the app is just a skin for the actual web content. You perform some setup. You say, hey, I'm going to join to this SSID, etc. Then the Echo will connect to the internet and do its stuff. So I spent a little bit of time seeing actually what happened during this whole process. So you load the Alexa app. You begin to set it up. It does a few things. So first, the app actually does a post to OOBE, which is either out-of-box experience or out-of-body experience, one of the two. So the app or the web page will post to the Echo device a payload of ping. It's basically a list or of a 1, the word ping, 1 and 0, and it'll actually reply with ping and an updated value to say, yes, I was able to talk to you, versus a ping versus a pong. I thought it was kind of interesting. So it posts this JSON payload to the device. You get a response to this. No information about it either, like there's no server info, so you can't really tell what it is. It's probably just a Kindle, as you'll see in a bit. The other things it does, so after it pings it and the application or web page sees it's online, it says get device details. And it returns a relatively large blob of JSON that has some interesting things in it we can kind of go over. Like this right here is device x.x.x, but with a build number. So I think they attempted to obfuscate which the actual version of the software is running, but they included a build number. So as you can see in the next slide, you can probably deduce which version it's running based upon this string. Another useful piece of information is the MAC address of the device. Maybe it's useful to you, maybe it's not. There's also a certificate it replies in the JSON data and the serial number of the device. So if we go back to the other slide, we saw the x.x.x 3077. If you go to this page deep in the bowels of Amazon device support, Amazon Echo Help, Alexa device terms, warranties and notices, source code notice, you actually download all the source code they use inside the device. So you can kind of see, hey, what type of libraries are they using? So maybe you could do things like, I don't know, find a vulnerability and report to Amazon and fix it. Or you can just kind of get an idea of what's actually going on behind the scenes. They don't keep their proprietary code in there, obviously. So if you want to be curious and download the tarball, look inside of it, you can take a peek. You see a lot of references to Kindle, which is pretty interesting. So if you plain text decode the certificate, you see it belongs to a place called Cupertino Lab 126, which, surprise, surprise, Lab 126 is an Amazon arm that does device management for Tide buttons, Kindles, it's a backwards iPad, and some TV stick stuff. So kind of interesting. They're the people doing the same development work as the ones who are doing the Kindle. So after you get the device information, like, okay, I need to join SSID so I can actually start communicating on the internet. So the application tells the device, hey, get the scan list. It goes a post to it. You need this big JSON blob, which you'll see several of these SSIDs are ones around my house. Looks like we have Sheep Goes Moo, Lucky Penny, Squishy, but the one we're looking for here is LOL plain text. That's the network I used to kind of see what was going on here.
Quick question.
Yeah.
How did you capture that? Through like Wireshark?
It's a TCP dump.
Is it TCP?
Yeah. If you're joined to the same network, it was plain text, you could see all the data. But if you also had like a network you were joined to, if you use Wireshark, you can supply the web passphrase and it can decrypt the traffic, so you can look at it that way as well. So it gets a list of SSIDs that the Echo can connect to. Then you choose one. So in this payload, I chose to connect to LOL plaintext, and it says, okay, I posted, hey, connect to this AP, and apparently it did so because 2 means success here, I think. Kind of interesting. I never actually figured out what I32 is or the rest of the payload. So this can be like a subtopic. People here, you can go forth and analyze what this means. Something interesting, so as soon as it connects to the internet via like a valid SSID, it does this thing, it does a get to spectrum.s3.com, or s3.amazonaws.com /Kindle Wi-Fi stub echo.html. I think this is just like a beacon page where they can test that you have internet connectivity. So it kind of it responds with this blob HTML that has a Python 2.5 UUID4 string generated in it. Maybe they have this like hard-coded in the Echo or the Kindle somewhere. It says, hey, can you read this value? Oh, okay, it's online. Cool. So it's kind of an interesting thing. So you can, today, when you go home from this event, you can relax and go to spectrum.s3.amazonaws.com /Kindle Wi-Fi and view this UUID and see what happens. The next step it does, it posts with the payload get link code. It says, okay, I think this is something to do, it's pure speculation. Like, has it been successfully registered to the AWS service? Yes and no. Interesting things to point out, you'll see later on. There's a user, so this is my iPhone doing the posting to the device, and it uses some weird thing in the user agent string called a Pit and GUI bridge. Maybe I'm pronouncing that improperly, or Pita and GUI, or Patan GUI. I don't know. But you'll see that later throughout the presentation. it responds with some 5-character string that says, yeah, I've got my link code. And it says, okay, well, are you registered? It replies with, yes, I'm registered, which I'm assuming 2 means successful. Get the Alexa connection state. Has it finished talking to Amazon successfully? Yes or no? And it continues to move forward. Okay, is your setup complete? Yes, my setup is complete. Now let's start talking to this thing. Throughout the whole process, these are the the endpoints that it actually talk to. So this is the most obvious one. There's also the PETA and GUI again, weird endpoint, DP, DW, NA, JS, API, Spectrum. That was for the Kindle, HTML blob. Pindorama, pins, first-TA G7G, that means. To-do, which I'm assuming is associated with the to-do lists. Then Guipiatan, whatever that is. NTP, which is cool, because so after this is all set up, all their communications TLS 1.2, so I'm sure they'd sign the request, the time has to be within a certain bound, so NTP's on the device. And they do softwareupdates.amazon.com. I actually didn't get a chance to capture when the update happened, so it'd be interesting to see if you bought an old, or if you bought an Echo and it came in the mail, if it would perform a software update and what that would look like. I didn't get to see that, but just it pinged out to here and it made the request just so you can know about it. So what the hell does this thing do? A basic feature rundown is when someone comes to my house, like, what can you do with this odd device? You can do things like music, news, and audio. So in the morning, you can say, give me my news brief, and it'll tell you the terrible things that happened. The weather for the area, some basic info. If you're cooking, you can say, what are 12 cups to ounces? It'll convert that for you. If you have any connected home automation things like GE's home automation stuff, you can actually connect the Echo to it and turn lights on and off and change your thermostat. You can set an alarm or reminder to wake you up or to take the turkey out of the oven. You can leave notes for yourself. You can make shopping lists, so you can be in the kitchen doing things and, hey, put eggs on my list, and when you go to the store, you can open the Alexa app and you can remind yourself to buy eggs. Oh, all these problems have been solved. So every time you make a request, there's a concept called cards. If I say, hey, so for example, in this scenario, you can say, I said, Alexa, play Jay-Z on Spotify. And to the corresponding voice request, it creates this card that kind of keeps track of what I did, so I can go through my history. It's almost like a timeline, so to speak, of the events I chose in Amazon. So if I tell it to do this card will be in there, and you can see what I did. Or if, for example, someone's at home and you're not there, and they're making sneaky commands or trying to play things they shouldn't, you can also keep track of that here, I guess, from like a Big Brother type state. Or you can ask for the weather, or what. I also try to ask what version it was running, just to see if it would respond and tell me. But obviously, it uses Bing for the default search provider. Can't imagine why, but so I think any request you can't interpret as a real directive, we'll just go out to Bing and search it, similar to your Series or your whatever the Google one is now. Does Google have a name, or is it OK Google? Okay. Anyways, so you got the thing at home now, and you're like, okay, you can just use the default out-of-the-box features, like, oh, I'm going to have it play Spotify in the morning, or tell me the weather. If you want to spend $180 for that, it's cool. Or you can decide to build a skill for it. So the skill framework is called Ask, which is a clever play on words, for the Alexa skill kit. And I'm going to kind of run through all the things you need to know about building a skill. So before I actually started building a skill, I assumed what was happening is, okay, I make a voice request, it interprets that somehow into some type of data structure, sends it to Amazon, does some things, and sends me a reply. As you'll see throughout the presentation, I think that's a pretty accurate representation with a little bit more complexity. So this is my assumption out of the box. Like, here's what we do. We tell it to do things, it talks to AWS, obviously, then it gives data back to us. So if you want to get started developing a skill for the Echo, you actually don't need to buy one. You can just register with the Amazon developer portal, and you can start developing a skill and use their software-based like text response things to test it out. So technically, you can be a developer and publish a skill to be used in public that someone could use, and you don't have to actually have a device. But it's helpful to have one. You can do additional debugging, because how you say things is different than how you type it in. So you can debug it through the web console by typing the words out, like what's the weather, what's on the menu at this restaurant. It's a little more cut and dry than you actually speaking it and interpreting the words. So after you buy it, potentially you register with the portal. the most key piece here is building your interaction model. This is basically how you're going to talk to and how the Echo is going to respond to you with data. The second important piece is building the Echo endpoint. So as you learn, this is just HTTP posting back and forth. There are two web services talking to each other. So you need to build some kind of endpoint to handle this traffic, do all the fancy processing, and build the proper structures to reply back to it. And so the third core thing you need to do is actually test it, because things aren't always as they seem. So starting the whole interaction breakdown, this would be an example like you would tell it to do, like, Alexa, tell ice cream bot to make ice cream. And in this example, let's say you had a internet-connected ice cream machine in your house. It would connect to it, then begin making ice cream. This is from a very high level. So there's a lot of things going on in here. When they take this request and they analyze it, they break down certain components, and they use that to build the actual HTTP request. Sorry, someone's calling me. My parents. So let's just break this request down a bit. So there's a few things we need to know, which is the wake word. So you have 3 wake words you can currently use to, I guess, bring the Echo from its sleeping state. It's Alexa, Amazon, or Echo. I typically use Echo at home. My wife complained that like Alexa is too much like a human. They call it anthropomorphization, I think, when you assign a human name to a non-human object. So I've elected to use the term Echo instead of Alexa, because I mean, it's 2 in the morning. I'm downstairs developing a skill, and I'm like, Alexa. It sounded kind of odd. So keep that in mind. You may be interesting. Or you can use the word Amazon. Every time someone says Amazon in your house, this is a wake word, and the device becomes aware and starts analyzing any voice traffic after that. So the wake word is triggered. Then the few things you can break down, these are called request phrases. So you can say, Alexa, it wakes up. You say tell, or there's a number of things you can do, like tell, load, play, etc. Where you kind of have a request phrase. Then it sets the stage for, well, what's the type of request or the application I'm actually going to start processing. So in this case, I would say, Alexa, tell. These are kind of the details of, you can do play, talk to, open, launch, start. So you can say play something on whatever, or you can say use this, or resume that, or load my report, etc. So these are a little more detailed, the request phrases. I think there's significantly more than that's presented here. So you can, like, I'm not going to like take a screen capture and show you. You can go look it up. So after the request phrase initiated, you have the invocation name. And the invocation name is tied directly to the skill in the portal. So in the portal, you say, I want to make something called ice cream bot. And in the developer portal, you tie your skill to that name. So ice cream bot is the name of your skill. Like, that's basically the name of your application, and that's how it's referenced. Then you have things called intents after that. So I guess we'll go into a little bit more about the invocation guidelines. It's got to fall within supported phrases. If you have like a 16-syllable word, it's probably not the best phrase, to use to trigger your device. So Alexa, tell Automatopoeia 1, 2, 3, 4 to do this. It's not a supported thing. Should be greater than or equal to 2 syllables, a 3-word maximum. I found that most words in the English language will work. You shouldn't use punctuation in the invocation guideline. And if you overlap, so if you started something like Domino's Pizza, it would be, so they have a skill registered with Domino's Pizza, so there'd be some confusion there, and there could be some overlap. I don't think there's actually, so if you went to publish this skill in the store, like, yeah, I want to publish a Domino's Pizza, they're going to deny you because it's so similar. But if you're doing development work on something that's a similar name, you're going to get overlapping responses. So their application could response, or if you say like, ooh, and burr, and like, obviously Uber, you could have some conflict there. So you have to worry about that. If you have like a new cool thing and it sounds just like something else that's out there, you're going to be in a world of hurt. So after you do the invocation, here's where the complex piece comes. It's called the utterance. I always think it was like you're uttering a word, so that's what they call it, the utterance. We'll kind of break down into that. So far we have Alexa, tell ice cream bot to make ice cream. So this is the application that we're running, and this is more of like the specific directive. We want it to make ice cream. This could be like shut down, do other things. So what if you want to do something a little more dynamic, like make a certain type of ice cream? If your internet-connected ice cream machine was so complex that it could make multiple kinds, you could use this, the dynamic utterance, to like plug in a variable and say like make garlic ice cream. So Alexa, tell ice cream to make garlic ice cream. So this variable inside of an utterance is called a slot. Yes?
Is the overall structure verb and noun? Seem to make
So,
All the other,
not necessarily. You could say like a what or how.
it has to be a verb.
I suppose, yeah. We could try it out. I mean,
Okay.
if I say tell Alexa or tell ice cream bot to do thing, I mean, it kind of makes sense in natural language if you're commanding something. Yeah. So it falls within that guideline. I guess it doesn't matter as long as the voice recognition here can map it to a word that maps to this phrase, which you'll see kind of down the line. It's all about, it's like, I think behind the scenes is like string mapping, as you'll see in a bit. So we have like dynamic slot in the utterance that says this can be any number of variables you can account for in your application. So this could be like chocolate. A normal person would put chocolate here, vanilla. If I put garlic, because I went to a blank slate. I had like basil ice cream last night, which was pretty interesting. So I thought, why in the hell not garlic? They make basil. Why can't I throw some garlic in there? So here's like a more specific voice breakdown, in case you didn't get all the pieces of it. Wake word, request phrases, invocation name, utterance, and slot. So let's kind of do it again. Alexa, wake word, tell the ice cream bot, which is our invocation name, to make, in this case, garlic ice cream. All right, this is cool. So there's another one too. This is another example to diversify. If we're not feeling the ice cream theme, you can ask the reports bot for my TPS reports for Friday. So in this case, our utterance would be my TPS reports. And Friday would be your dynamic variable that would.
Make your utterance all slots, or does it require some type of?
You can have an utterance without slots if you want.
No, the other way around. Like the utterance all slots. Or does there need to be some static wordings in there?
Well, when we talk about like the next slide, I think when we talk about the JSON breakdown, we'll see. So there's a piece that's missing from here that kind of connects this back to your application. So we have all these pieces of text. It's like, well, how do I, when I write an application, do I say, do I look for the string my TPS reports, or do I parse based upon this, or do I do something on a variable? So how they handle that is they have a thing called an intent. So they take an utterance and they translate it into an intent. So based upon these few words that I'm directing, I can assign it to like a variable that I can reference in my application. So for example, make ice cream utterance is tied to the intent of make ice cream. This can be anything you want, but I just made it easy to read and associated. So think this is like a variable that you later reference in your application. So if someone's saying make ice cream, it's going to say, okay, well that translates to this one word string. Then I can in my application be like, well, if my intent is make ice cream, then I can do the certain type of logic on the request from that perspective. Similar down here, I have an utterance plus a slot. I still reference it with my intent. Does that make sense so far? You want to go through it 10 more times? All right, we'll keep going. So luckily, when you go to map all this stuff out, it's all JSON based, as most web request things should be. So for example, in this application, we have the intent. If we go back here, we see the intent is to make ice cream, and I tie it to a text phrase. Say, well, make ice cream, and I want to be able to put these type of flavors in here. So here's the weird part. I have to predefine my flavors. I can't just come up with a random flavor and expect it to recognize it, or a random slot. So for example, on the make ice cream intent, I have slots that you can supply a flavor or a variable, the kind of ice cream you'd want, and you define it here, like the type of ice cream flavors. Then down here, I have to actually define this custom slot and say, well, here's the ones I can put in here. I can put cherry, mincemeat, garlic, vanilla, or chocolate. Hey, keep an open mind here. So if I then spoke to this application, I said, well, I need you, ask ice cream bot to make blueberry. Since I don't have the custom slot defined, it's not going to know what to do with it. So that's cool.
Is name and type two different predefined variables, or?
Yeah, use the squawk box.
Oh, I was just wondering if is name and type, are those both predefined, or is it just type?
So this will connect in a second. I'll get to that. So type references the custom slot. This could be something that's built in like a number. So why define every single number that's available. So as you'll see in the next slide, Amazon has built-in intents. Like you can say, if this is going to be a number that you're going to speak in, it'll recognize a number. So I don't have to define 1 through 3,000 down here. We'll get to that in a second. But we'll answer your question shortly. So here's some example of utterances that tie to intent. So I'm going to have this whole list of things. I need to predefine all the scenarios that someone can say to initiate this task. So if someone can say, make ice cream or make ice cream please, I have to account for that language structure here and tie it back to this intent. Like, so make ice cream would call the make ice cream intent. Make ice cream please would also call it make flavor of ice cream. This is where your flavor is tied to. So see here, you reference this variable. It's got to be unique and reference it here.
What about other orders of things? Please make. What about other orders of things, like please make garlic ice cream?
So this will handle all the predefined
The predefined
flavors. So you see,
yeah.
the variable name is flavor. It's a type that I define down here, and it'll actually build the voice recognition based upon this. So when I supply these, it's like cherry on the back end. It's like, oh, cherry is going to sound like this
Yeah.
to an English-speaking person.
Using it in a different context, tell me Friday's weather. Tell me the weather for Friday. Tell me the weather tomorrow.
Yep. So you'd have to actually identify
All
those
of those?
those phrases, but you could use the same variable because you'd speak it just in different order. So here I could say, would you please make flavor, like, would you please make garlic ice cream, please? I'm going to say that. Then I introduce some other ones down here, like make a waffle. So you could see if I had another function in here, like my ice cream thing not only makes ice cream, it also makes waffle cones. I could also supply the intent of make waffle cone, and I could say, oh, then I define that English language right here, and it ties back to the statement. All right. This is like a college econ class. So if you were to like, they were pretty separated before. But if you tied it all together, if you're in the Amazon developer portal right now, and you wanted to make a skill that did this, you'd have to fill in these three things: your intent, which is to make ice cream. You define the English-related phrases to it. You define which flavors you want going into it, and it would actually, behind the scenes, every time you submit this, it takes 5 to 20 seconds and actually build the skill in the background. So the skill is not quite ready to be used. It doesn't take too long, but it'll let you know when the skill is ready to be used. So I'm assuming on the back end what it's doing is doing some type of like algorithm. Says, okay, this is what it's going to sound like from a phonetic perspective. This is what it's going to sound like from a phonetic perspective, and it'll figure this out and build those in the back end. And this is just kind of answering your question before, that flavor is tied, the name of the slot, you can reference it here in curly brackets, and the types are defined here. Yep. So they're all connected somehow. So if you had if you had a slot, I guess I just spelled this the British way. I realize that. If you had something else here and it wasn't defined in slots, and you attempt to save this skill, it'll complain. It's like, hey, I can't map this variable back to this type. That's where it becomes difficult. So if I'm going to have an application with 60 different outcomes that are not natural language, like a number or letter, I need to define those in my kind of like voice profile. There's that. So here's where we get into the built-in slots. You can do things like Amazon number. So back here, if I wanted to make a new slot that said number of scoops, I would say I'd create a new item that said name, number of scoops, and the type would be Amazon.number. So I'm not required then to like, oh, I don't need to put 1 through 50 in this list because it doesn't make any sense. So they build these in behind the scenes. Also things for like date, you can say tomorrow. It'll translate that into like an ISO format of like, July, whatever. So if I said tomorrow, it would be tomorrow's date in the ISO format. Or time, like, hey, do this at 4 in the morning. It'll actually, behind the scenes, you don't have to define these variables. The back end will do it for you. Things like duration, in 5 minutes, remind me of. There's several others. And they add new ones all the time. So if you subscribe to the blog, they'll email you with new updates every week. So those are built-in slots. There's also things like built-in intents. So if we go back and look at, oh man, what is this? Sorry about that. If we go back and look at the intents, like here we're defining our own, like make ice cream can be these phrases. You don't have to do it for basic ones like okay. They have that predefined already. So I don't have to spend the time writing an intent to be like, if someone says no, I don't have to build that into my app. They automatically take care of that for you. So if I say no or help, never mind, forget it. Shut up is in here, which I thought was a pretty risque one to do. Yes, yes, please, and sure. Anytime you say yes, yes, please, they automatically know that in the back end. Like they build the language construct for that, and they can interpret it for you. So those are the ones that are kind of neat and save some time. So you can also extend ones. If there's one, you can see on the previous slide, there's one that says, if you say help, that's automatically interpreted as an Amazon help intent. Or you can extend it. If you had like a taxi corporation, you could say, help me order a taxi. And this would also, so the words help or help me order a taxi would call this intent, which later on in the application, this is what you need to analyze to see like what's going on and how you need to react. All right, so yes.
Can you have two slots in the? Oh, sorry. Can you have two slots in one command? Like echo, can you tell the ice cream Bob to make me 2 scoops of garlic ice cream?
Yes, you can.
Okay.
Yep, so you can have multiple slots in there.
Sure.
And they have to be, I believe they need to have a unique name, but they can have the same type. So you can say like, do 2 things and 4 things, but the variable it references in needs to be unique. So it'd be like first value or second value. So you could have as many as you want. I mean, there's probably, knowing Amazon, there's probably limits. Like if you're AWS users, there's limits for everything. So I'm sure there's like a 60 slot limit or something like that. I don't know. I've yet to encounter that, but that could be potentially be a thing. So elaborating on our initial slide of, hey, probably post some stuff and get some stuff back, and that's how it works. We're going to see that's really the case. So behind the scenes, it's actually, if you read the documentation on how to build the responses, you're just constructing JSON blobs. So when I talk to this thing, it basically creates a blob of JSON, posts it to my application, and I process it as I see fit. And I also return a piece of JSON that the device will then consume and reply appropriately. So kind of the high level, like here's what happens. So great, we've defined all our natural language of how it's going to respond and what it's going to do. Now I actually need to build an endpoint. So it's just a basic HTTP endpoint. So it's got to be internet accessible, TLS only. Now you can use a self-signed certificate, but you actually have to upload the private key to Amazon, or you can use a third party. So if you do build your own endpoint, let's say like you build it behind 3 boxes with the load balancer, you have full control over the runtime you use. It can be any application or any type of code you want, any language, how much you want to scale it. You need to manage the endpoint security, all that stuff. You're responsible for full management of your endpoint. Then along comes a spider. Alexa scales as a Lambda function. So instead of like building out a bunch of servers and load balancers and endpoint and managing certificates and all this super troublesome stuff, it's just like an infomercial right now. You could build it as a Lambda function. So I'll kind of give a brief high-level overview of that. Next slide. You point your skill at the Amazon resource name, which is Amazon's decoder ring for services. It's fully managed, it's scalable, it's inexpensive. I think you get like 1 million requests for free, true or false? So if you're going to build a skill, it's going to be under 1 million requests. Probably the way to go. If you're going to build the next cool thing, though, even if you do get 10 million, it's probably like $5, whatever. There's also a constraint. You can only you can only connect the echo to a Lambda function in East. So if you're a big East hater like I am, can't use West. So that's no fun. So Lambda 101. I think the next, oh yeah, there's a hat. So you give the command to your device. So what basically Lambda is a place where you, super high level, you paste your application code into it, and it does things like when it sends a request, it'll run the application code for you. So you don't need to maintain infrastructure and do security patches and all that. It's like I have this big text box I put my Python into, and when it's initiated, it runs the application. It assumes a role, like, well, if I need to access my certain Amazon resources, it'll assume a role that it's allowed to do certain things. It'll talk to Amazon and so forth. So, for example, I created a function today is, this is the Amazon resource name for it. That's my account number. Yeah, right? And that's the function name. So that's kind of what Lambda is. Any questions about Lambda? We want to get into that right now. It's basically a place to run your code. We don't have to worry about managing infrastructure. All right, so this is kind of, if you go through the documents of how these things work, you'll see, again, JSON blob has some things like the version, some session details, whether it's new or not, unique ID that identifies your application. So when you first define your application in the developer portal, it'll have a unique application ID that says, this is my like social security number for my skill. And I'll show you why that matters later. and some other stuff we might not care about. The meat of it is the request, though. So the request is all the type of stuff that's going to contain our intent, like that variable of how we're going to execute, things like our variables, our slots, how we're going to process them, and going forward. So we post this data to our service, and we can return 3 types of requests. A launch request, so if I say things like echo, load commander. Slow internet.
Welcome to the AWS Lambda. How may I help you?
Cancel.
Okay, goodbye.
That was very polite of it. So that's a launch request. I don't actually deliver any intent. So all the examples I give you before, it's like, Alexa, tell this bot to do this certain thing. That's more like an intent request, as you'll see next. But this was like a launch request. So you could use it to launch your application. It's like your main menu for developing a skill. So I could say, Alexa, launch ice cream bot. And I could say, oh, welcome to ice cream bot. What do you want to do? That's one option. Or you can just dive right in and say, Alexa, do these things. That's considered a launch request. So you have you have the launch request. We have the intent request, which you specify specific things. Then you have a session ender request, which I haven't got into too much. So we're basically going to cover launch and intent. So this request object becomes this big blob right here. So if I say echo or Alexa, tell ice cream bot to build or to make me garlic ice cream, the slot will be flavor, what the value was, and the intent will be called make ice cream. And we'll see examples of these later on. So basically, the application you write that's going to handle your stuff is this giant if statement, like most things. So if this and that, if this and that. So if it's a launch request that comes in, you're going to have a launch request function that says, oh, here's what I do when I launch. If it's an intent, you're going to pass in the data. You're going to analyze what that phrase is, do appropriate things. Else, say, I don't know what you mean, cancel. So here is a more detailed look. If I were to create a request, I need these type of variables that are my minimum required. So I need things like the card, which I remember I showed you earlier. The card is the little text-based application window that exists in the Alexa app or the website that tells you what requests you're making. So you can use the card field to build out things like, oh, here's the title. You can have content in there, like show images, etc. This is where you supply the output speech. So for example, I'd reply with this blob and it would say, the type would be we'll go into that in a minute, but it would just be text or SSML, which we'll talk about next. Now, if you want to maintain state in between requests, so these are stateless requests. I say a thing, it does some work, and it gives me information back. It doesn't keep track of like a session. If I want to pass data between these requests, I would put that in the session attributes field. So there's some I ask it to do something, and it's like, are you sure? There would be some data in there. It's like, oh, I'm in this function right now. It would send it back. It would bounce the data back and forth. So it's like a state tracker, basically. So the cool thing is the speech synthesis markup language, SSML. You can choose to have it reply just a plain text string. So in the reply, if you build it and just have text, it'll read the text back to you. Or you can do creative things like have it interpret numbers. So if you construct it, it's a markup language for how it communicates back to you. So you can interpret as cardinal, it'd be like 12,345. But if you interpret as a digit, it would say 1, 2, 3, 4, 5. So you can control how it responds to you in natural language. You can have it spell out words like hello. You can have it do phonetics. For all the linguists in the room, they can interpret this. That's what it means. You can have it do pauses. So it's useful for things like you're waiting for a piece of information or someone might not reply quickly. You can insert a natural pause in there. Or you can have it just it's interesting, they have the paragraph tag, which is just like an extra long break. Or you can have it play MP3s. So you have some business where you have it's like a welcome to so-and-so. You could say echo load this app, and it would then play like an MP3 back to you, like, oh, welcome to blah, blah, blah. And it would be like your tagline thing. Because you don't want the echo to butcher your tagline, so you'd use your pre-recorded audio. You can store it in an S3 bucket, obviously, so Amazon gets more money. So this is how you would manipulate language that's replied to have it speak as you want it to be spoken. So here's like a launch example. If I had an application where I'm like, echo, do this, or launch this type of thing, this is what it would look like. So your application would read this request and be like, oh, the request type is launch. So I would dispatch, I'd build a response that's going to be the type of launch request, and it would get like a main, it would prompt you the main menu to be able to do things. There's an intent request example. So if I said, this is from the, I should have changed it to be ice cream, but it says that they use a horoscope. So for example, they use the term get, so you ask, get the zodiac sign for vertigo, and it would tie it to that language would be tied to this intent and this variable vertigo. And you'd build your application, you'd say, oh, you're going to have great luck this week, whatever. So this is what the response would look like. If you did plain text, you just put generic plain text in and it reads it to the best of its ability with no phonetics involved. You'd create a card that had the horoscope with the title and some information about it. And there's also a third piece called reprompt. So if it repeats a skill back to you and you have reprompt enabled, or it doesn't understand what you're trying to say, it'll be like, oh, like, what did you mean to say? Can I help you with anything else, etc. There's also a piece of data you can implement that when you speak to the device, it can speak back to you and you can end the session. That's called should session end. So if I speak a command to the Echo, it's going to do something and it shouldn't do anything further, I can say should end session true, and then our conversation will be done. Conversation's over. So here's just what it looks like when the session's over. It would post its data back, yada, yada. So to make this easier, I wrote a Python library called PyAsk. We can actually, instead of like, who wants to do all this, write all this stuff, you know? Not me. So I wrote this thing. You can download and check it out. You can build a response. You can say, I want it to be security markup language. It'll say hello there. It'll build a card of that type. That's incorrect, so no. I should just return this. Anyways, you can go check it out. This is an easy way. It's a Python library to build the responses for the apps. This is like the core of going forward, how we build apps and manage Amazon. If you want to test your skill, you register it. It has to build the language model in the background. You enable the test, so there's like a flag. So my device is tied to my developer account, so any like developer skills I make, and it's aware of them, and I can exercise those. So no one can actually use their Echo to launch my skill because it's in development mode. It's got to go through their app store and be approved. So from a development perspective, or if you want to do VoiceOps in your organization, you would never publicly publish the skill because you don't want people to use it. There's ways to prevent that also. So you just enable testing on your device, and you can make as many skills as you want and keep them private in your own home, and no one else can use them. So we have the tools, we have the talent. It's Miller time. Who can tell me what this quote's from? Come on. The movie was, yes. Good job. Yeah. Ghostbusters. So I actually made a few. The goal is like I want to explain all this shit because you need to realize what goes on, but to make it a simple skill. Like on the back end, these things I'm going to demonstrate next are all basically things you would do in your general AWS administration pieces. You'd use Bodo, you'd write all these administration scripts. But instead of presenting command line arguments, you're using your voice to do things. So here's the first one. We're going to do this live demo and actually see if it works. So this does a bill report. It'll actually look at CloudWatch data for my current Amazon account and tell me how much I owe. Okay, Echo, load commander.
Welcome to the AWS Commander. How may I help you?
Get my current bill.
Your AWS bill is currently $3.69. You cheap.
So Easter egg, if you put profanity in the response, it'll actually bleep it out. I thought that was kind of cool. But you can get tricky with it if you, so you separate ass and hole, it'll still say it. Yeah. So hack there. So that was the first one. That was basically, all this did, it exercised a Lambda function, looked at my CloudWatch data, generated the results back. Next one is, this one should be a little more complex. So I have a regional failover. Let's see, can you see the screen still? Or is this resolution going to be too terrible? So I have this website called plinko.mfdt.de. It's currently operating out of the East region. And I can use the Echo to actually fail it over to the West. So we're going to try this again. and see if it works. Echo, load commander.
Welcome to the AWS Commander. How may I help you?
Failover to Oregon.
You should receive a SMS passcode in the next 5 seconds. Say, my passcode is, then your 6-digit number.
My passcode is 229252.
Failing over to Primary Region West. Can I help you with anything else?
Nope.
Okay, goodbye.
So polite. So technically, the TTL on this domain, oh, look at that, failover to West. So behind the scenes, I had it change the weight on a Route 53 DNS record, and it pointed to an instance in West. And the cool part, which is Duo's going to appreciate, but I didn't use Duo, so it actually created a random 6-digit passcode, texted it to me, so I couldn't actually fill that over unless I knew the passcode. So if you tried to use 229252, the internet people out there, not that you would be able to access a skill, it wouldn't work. So that's kind of a neat thing. When I was playing around with this, actually my wife was like, couldn't just someone come up and just change, fail your site from one region to the other? Yes, they could. That's why I put the passcode piece in. So kind of neat. That's demo number 2. Demo number 3 will be auto scaling. So Amazon has a feature where you can auto scale some systems. So let's take a look at this cluster I have right here. So I have this cluster of machines that has 3 in it right now. We'll go look here. We'll verify, this is not a magic trick, that there are 3 ECS cluster instances. And I'm going to attempt to scale these out using my voice. Echo. Load commander.
Welcome to the AWS Commander. How may I help you?
Scale the containers cluster up by 2.
Okay, scaling the containers cluster up by 2. Can I help you with anything else?
Nah.
Okay, goodbye.
So they actually behind the scenes, they built the intent that recognizes nah as no, and they escape that for you. So if all goes well, look at that. 2 new hosts in the auto-scaling group being created. Why the hell you want to do this? I don't know, but it's kind of cool. This is an attempt to solve all the operations problems, in this talk would be kind of ridiculous. Everyone has unique problems. This kind of shows you that, hey, you could do cool things. You could have some user experience ops center where someone could walk in and get this. How many orders do we have per minute? And they could do cool things like that. So just to illustrate that. Another one, which is kind of boring, but you could perform a snapshot on all your volumes. So you could say, Echo, tell Commander to perform a snapshot of all volumes.
I'm performing an EBS snapshot on 6 instances. Can I help you with anything else?
No, thank you.
Okay, goodbye.
All right, so we did that, and that actually worked, so that's good. There's one that takes a little longer, but I have this, I'm not going to do it. It basically deploys a new Docker image to a fleet of containers, and you can see, for now, version 1.0 is deployed. I could tell it to deploy 1.2, and in 5 minutes, it'll orchestrate that. So we'll do that, but we'll do some other cool ones in the meantime. So Echo, load commander.
Welcome to the AWS Commander. How may I help you?
Deploy version 1.2.
Deploying version 1.2. Can I help you with anything else?
No.
Okay, goodbye.
So this is an interesting problem to solve where I was trying to dictate application version deployments 1.4.5. You can't actually dictate in decimal points, so I just separate it by version 1, 2, 3, and those were separate intents. And I'll show you all the language. I printed this page out because there's a million different, I kind of cheated here, a million different English interpretations you could use. I didn't want to say it wrong. That's why I printed a piece of it. So if you, what's he looking at? This is what a cheat sheet. This is exactly what I'm looking at. So there's one last one, which will be security-minded, and it will be Echo. Tell Commander to give me a CloudWatch alarm report.
Here is a snapshot of your CloudWatch alarm state. There are 2 items in the state insufficient_data. There are 2 items in the state OK. Would you like to hear some more details?
Yes.
Request count is in an insufficient underscore data state. Elb latency is in an insufficient underscore data state. Request count is in an insufficient underscore data state. Request count is in an insufficient underscore data state. Elb latency is in an insufficient underscore data state. Request
So,
count is in
like,
an
there's a loop problem there.
insufficient underscore data state.
So we've encountered a real live bug.
Can I help you with anything else?
Nope.
Okay, goodbye.
So that was a recap of CloudWatch alarms. Kind of interesting. One last one I'll do is echo. Tell Commander to load my security report.
There was a problem with the requested
Oh,
skills response.
Okay. This is where I have this cool thing here. Maybe it'll work. It should tail the logs and tell me what the problem is. We can fix it in real time. Probably not. Try one more time. Echo. Load Commander.
Welcome to the AWS Commander. How may I help you?
Security report.
There was a problem with the requested skills response.
Okay, so that one didn't work. Hey, we're like 5 or 6. That's pretty good. We should see in a second what the yeah, we'll see what the problem was. So the interesting thing is, if you have a Lambda function, it sends all of its logs to CloudWatch logs. This thing should tail the logs and tell me what the problem is. We can fix it in real time and all this fun stuff, maybe. Oh, this should be separate. So what this one was supposed to do is actually read through all your CloudTrail logs and find interesting events and parse a JSON, like give it a report back of like 10 people logged in with the root account, or 6 people didn't use multi-factor authentication. So I'm not quite sure why it worked, but you know that's what it was supposed to. Trust me, it was going to work. It worked before, maybe not now. So those are all the demo items I created. We can kind of quickly walk through what the intents would look like for this. So this is the suite portal. Make this a little larger. Hopefully it logs in. So you go to apps and services. There's an Alexa section. And here's where you do things like define all your skills. Let's get started. This is the one we want right here. So there's some other custom ones. Like I have one for my kid. It tells him what he needs to bring for the day. Like if he has gym, bring your shoes, because I'm too lazy to write on a piece of paper. So why not use this $180 tube? So if you look at so here's the skill I built for this. I defined the invocation name, which you heard me call like echo load commander. That's the word right here. I'm sure in the public store there may be something called commander, and it would be conflicting. You specify which Lambda function all my code existed in. Now here's where the hard part comes. This is where you built your interaction model. So for the intent get AWS bill, I don't have any slots because there's no variables. I just tell it to do something. You go down here. So I defined all the different types of language that would call this function. Same here, like list of regions. I statically define the regions as Oregon, Virginia, or East and West. Here's a built-in one of Amazon numbers. So if I said like, the website, the failover one I used, you could also weight it. So you could have like 50-50. You could provide 2 weights also, like make East weight of 4 and West weight of 2. You can do things like, here's the auto-scaling group adjusting intent schema. So I said like the scale action, you can do up or down. That's how you manage your auto-scaling groups. And by the number you want to scale. I don't want to define 1 through 10, so it actually will do that for me by the built-in type. The snapshotter, which I can also provide an EC2 instance tag, and it'll snapshot an instance based upon tag. Deploys the app based upon the minor immersion number. So if you asked earlier, can you have multiple slots with the same thing? So yes, I have app version major, app version minor, they're the same type, but they're defined differently down here, as you'll see. So I can deploy version, major version, minor version. Those are just numbers. Then you can go to do things like tests. So you actually type in like, get my AWS bill. Here's where you actually wouldn't need a device to do this. I could say, get my bill, ask it, and it'll actually exercise the function and give the response back. I can hit play.
Your AWS bill is currently $3.69. You cheap. Can I help you with anything else?
So there was a good one there. Let's see if there's actually deployed version 1.2. Oh, look at that. went from 1.0 to 1.2 in the back end, so you can do, if you're super lazy, you can do a deploy. So just some interesting ideas, things you could do. Now go forth and buy an Echo or not. It's up to you. That's all I got. I think we're like an hour so far. That's good enough.
Is Alexa listening while it's on mute?
Here's an interesting thing. So if you go back into you sign into either your app or the Alexa page, it goes through and like has all the skills. Like when I ask for the bill, it'll tell me the number, but also tell you what Alexa heard. So
Security report.
that's a piece of text I used, and they recorded it, and it's probably in an S3 bucket somewhere. So it's up to you to decide whether you trust this with your data. Now, on the other hand, is that the mute's on now. Is it listening? It needs to be like an electrical engineer that needs to figure that out because there's tiny like embedded microphones in the device. So something to think about. You can actually go on you can log into your Amazon account and choose to remove all the voice data every day if you want. You have to manually do it. But they say, please don't do this. It helps us build a more intelligent voice service. So it depends what your level of comfort is if you want to do this. What do you think? Do you think it's actually listening in the background? Maybe. It's obviously always listening. Was it sending traffic? I don't know. You can attempt to analyze the data and figure it out for yourself. But it's encrypted, so I actually didn't try. I wanted to do before this meeting was do a kind of like man in the middle it, see if I could provide like a different certificate. If I could see the traffic, but I didn't get that far, so somebody else should do that. Like Mark Stanislav should do it. He's like the hardware hacking guy, so that's yeah. Yep. You can do things in here like set your device up, which I found out later. I was like, oh yeah, I found out the version, man, from the payload. You actually just go see it right here. I thought it was cool, spoil later on, and the serial number and the MAC address. There's also the interesting thing, maybe it's, there's some other stuff about like the Pigeon GUI bridge, whatever that is. Like, I don't quite know. So you could also choose, change the wake word here. Things to try, blah, blah, like these are all suggested phrases, skills you could activate. Smart home, you can turn up the heat in my house if you want. Timers, alarms. This is kind of a rundown of all the features. If you do have it linked with Spotify, which I obviously do, it's the last song you played, or if you can use Prime Music, etc. So, yeah, if you feel cool with like your voice being stored, Amazon, if you trust them enough, then it's the kind of decision you have to make. There should be further research on it to see what's going on. It'd be cool to find out. So that's all I got. Hope you go buy one and build some stuff.
I saw that you had it set up for your son's computer, I believe. What are you doing?
Voice, or anybody's voice, but he could ask it to return certain things, like what's today, Monday, then.
So it's not gonna you can't. Are you able to say start web browser?
No. So this is like these are all out of band. These commands. So this code's running on an Amazon instance. So like here's the Python behind the scenes. So this is happening behind the scenes. You actually, you don't have to have it. You could have it start a browser on a computer, but this code would have to be able to talk to your computer and execute that. You need to set those privileges up accordingly. So this can basically make another, it's a giant if statement that can make another web request to do anything you want. There's also like IFFT, if then that integration. There's some interesting stuff people have done. But I'll put this on GitHub if anybody's interested in seeing this. And it's like obviously not any Python developers here. It's not PEP 8. It's too wide, But sorry about that. It's just like I'm building a sentence for the presentation. I didn't want it to be super pretty. But so this is like to do those basic commands. This is about 600 lines of Python.
I'm curious on how bad you would have to speak in order for it not to respond, vis-a-vis you had to use a cheat sheet.
I use a cheat sheet purely for like the phrasing, right? I want to get it right.
Right,
like,
right. How bad, if you didn't
have...
have...
as much of dictation as much as like, would I memorize the exact order of these things? If you're going to build an application that's public-facing, like your consumer application, you're going to make it as easy as possible. Right? But if it's more of like an administrative...
as variable as possible.
You're going to make it, yeah.
And so can you speak to that with this device? can you, I don't know what you have in the way, give us an example of, this is what I would normally say, but I can also say this and still get the same result.
That's why you can define multiple utterances.
Just from what you have in there, can it determine that you're using keywords in maybe two of those utterances?
It could get confused, sure. So earlier when I was tweaking it and I didn't have something quite set up, gave it my passcode. My passcode was a series of numbers, and it became the triggered deploy version. So I mean, it's all based upon if your language is unique enough. If you're gonna have intents with the same type of language, similar, they're gonna have some overlap. So you're gonna have a goal to like make them as differentiated as possible. Yeah, sure. You want to throw the box to her?
I'm sorry. So if you downloaded a skill for your Echo, is there anything like a manifest that you could read what exactly it will do? In a sense that, let's say I downloaded an ice cream maker bot, but would it go and turn on my coffee maker in the morning?
I mean, so if you enable a skill that's published in the skill store, you're going to have any visibility to that. If you're defining your own skill, it's going to do whatever you want on the back end, you have complete control over. So if I go to enable, like, I don't know, my Capital One skill right now, I can't really see what this is doing, like what the data it's posting. So like they're taking my text, interpreting it, and sending it to some Capital One endpoint. It'd be interesting to see though, like maybe see what one of these do, like the pizza ones or the car ones, if what they send. They're all encrypted, so it's difficult to see what it's doing. But you don't get to like you enable a skill by publicly available skill. As I hit enable, and my account can then use that skill. So I have the visibility I have into it is this is it for a publicly available one. That's all I see.
Okay.
Now, if you do some reverse engineering, you might be able to figure out where it's hosted. You could do some recon from that perspective.
They have instructions.
Or if you could intercept the traffic somehow.
Two questions. As far as like a privacy standpoint, does it always interpret your language first and then only send the I guess interpretation to the endpoint, or does it ever send or can the skill request the raw voice recording?
So whatever I say that's attached to that skill, it'll send it to the endpoint no matter what. There's no pre-processing. It says, oh, he wanted to do a failover. I'll only send that traffic. Like if I make up some new skill, like commander, like count to 5, it's going to send that data to the endpoint. The endpoint's going to be like, I don't know what to do with this. The giant if statement's not going to know what to do. It'll return. It'll just say, you can build that in like an intent unknown. I don't know what you mean. So it'll send it either way. Does that answer your question?
Yes.
You had 2.
I know. I forgot the second.
Okay. We'll do like 1 or 2 more. People want to get home. It's like late or not.
Do you have any control over training the recognition of a particular voice, male or female, or with an accent?
Not that I've seen, no. It's purely just.
So it's a generic.
Sauce in here.
Okay. And do you have any control over the voice synthesis? Female, male voice?
It's just as far as I know, you can control, like as I talked about the speech markup language. You can control how it's spoken. I think it's the same female sounding voice every time.
Okay.
It's Alexa, right? You can't have Chad start to talk one day and it'll sound different. Maybe there will be. I think that's the number 1 request. People want different wake words. Viewing the forms, they want like language choice.
All right, I remembered.
Okay.
Does it have, for utterances, does it have any like special capabilities for interjections or other linguistic artifacts, like saying, or anything of that nature?
I haven't really got that far to like I build a specific language pattern and I speak it to it and go to that point. I mean, I don't know how it interprets an It'd be interesting to see, and you can output that data. Let's see if there's actually any. Yeah, or like. Yeah.
All right, thank you.
Sorry, I don't know. Good? Any more questions? All right, last one. Unless anybody has any more.
Okay. Well, actually, it's not a question. Just want to share some information online. I did see the video of a guy build Echo by himself. So what you need is a Raspberry Pi and a USB sound card and an external speaker and a push button.
To do what?
To build an Echo, a similar device.
Oh, yeah. So there's a thing
Yeah.
that
So-
they advertise. Let me get this real quick.
The only thing is missing is the voice active function. So
Yeah.
you have to push a button to activate
Yeah,
the
so
device.
they built this thing called Alexa Voice Service, which is basically you can add these voice capabilities to your hardware.
Right,
That's an interesting point to talk about. I should include this one, but you can do that.
right.
So like if you have your own hardware behind the scenes, you can listen to it, interpret it. It's basically to add the service to your connected devices. So I see people doing this? Maybe. I don't know. Good point. There's no cool acronym in them, though. This one's ASK. This one's AVS. You got to work on that, I guess. All right. Thank you.